Hello, good evening, everyone. Welcome to the Saturdays for Sustainability Learning. We are connecting with a goal to discuss sustainability and understanding sustainability in a holistic manner. If you have joined for the first time, if this is your first day, I'll just recap what it is and why we are connecting, so that just to remind all of us how we should, let's say, go ahead. So, this is nothing but a mastermind group, so peer-to-peer mentoring, helping, supporting each other to learn one new concept every week. Okay. This is a request for everyone. So this is not as such means a one-way communication or only one person is talking. So please feel free to add your inputs and your expertise. So that's highly requested, recommended. And if you are joining, so time is the most precious commodity that we all have. So these are the four outcomes from this 1 hour we are expecting. That is learning new concept, one new concept every week, every session, networking with fellow professionals, learning new opportunities, and the thought leadership, of course. And if you ask me, two foundations for this session is first is data, information, knowledge, wisdom. This is the pyramid. So we have more data and more information in today's time because this is the information age as we talk, right? But knowledge and wisdom, which comes with experience, with understanding, that's something we lack. So that we will try to get from the experience of the fellow professionals and experts. And second is the discussion and question and answer is a basic and the best way to learn. So please feel free to add your expertise, add your voice to this discussion. Please share your understanding of the topics, your own point of view, so that it enriches the view of others as well. And if you have joined this call, so I hope you have already registered. It's free of cost registration, but it will ensure that you will get the calendar invite, and that's how you will get continuity. So if you haven't, so please do so, and we will also coordinate and keep communicating with our WhatsApp group. So that's why registering is important. All right. So I'll just quickly introduce what we are going to do today. So today is a session 68, week 68 for us, and I'm very happy to share today we have one very interesting topic, hydrogen economy, and a topic of recent interest and at the same time lot of confusion as well because there are many types of hydrogen, gray hydrogen, green hydrogen, and blue hydrogen and whatnot. So multiple things are there. And I'm very happy to share Muralidharan sir, who is very senior in sustainability. He is expert in social accountability, and he is a constant learner as well. So it's wonderful to learn from Murli sir. So I'll stop here, and Murli sir, floor is yours. Thank you so much
Yeah,
first for sharing your knowledge.
my
Please.
pleasure, Dhananjay. So good evening to all of you. And for me, like I joined Dhananjay when this concept came, and ever since I have been a regularly irregular person, I would say that, for the simple reason that I attend some of the sessions and also contribute to his efforts. It's been a wonderful journey, and I hope that things become better in the days to come. So, with that introduction, so let's get into this hydrogen economy. Hydrogen as a fuel for decarbonization and the current trends, as all of you will know. And Dhananjay had also sent a couple of articles you must have gone through, that the hydrogen economy is likely to boom. This is the first thing. And of course, it has its own challenges. And also, we need to understand something more about hydrogen as a fuel, though it has been in existence from ever since from the Big Bang process which happened in the world. So let's go through each of the things from fundamentals so that it becomes easier for everyone to understand about hydrogen, about the hydrogen economy, and also the challenges which the industry is facing. And we will have a question answer session, right? And I would like to ask only one question in the end to all of you, right? So that will validate what I have been trying to speak. Fine. In case I forget, just give a reminder, Kulkarni sir. Okay.
Sure,
So let's
sure.
go about hydrogen. Hydrogen is an interesting element. If you see that it's abundantly available. If you really, we go back to the schools, we must have school learning. We must have read about the Mendeleev's periodic table, wherein on the left side of the periodic table, top corner, hydrogen figures in that. And subsequently, when the modified periodic table came, there were other elements which got added into the uh, periodic table as rare earth elements. So I just want you to remember this because it is important for our discussion now. So rare earth elements from 54 period, the atomic number 54 to 64, something like that got added, like lanthanum series and gadolinium and various other elements got added. So when we look at that, hydrogen has been there, and the entire organic chemistry or aliphatic aromatic chemistry or the chemistry of hydrocarbons, when we look at it, hydrogen is there in most of these compounds. And when we synthesize more, hardly we can find any compound minus hydrogen. So it's abundantly available on Earth, and we know the byproduct of H2O, suppose water is split, then we get hydrogen and oxygen, and we have all read it in our schools and colleges. Now, with the recent trend, hydrogen as a fuel is being looked at, that whether it can substitute, it can be a very good substitute for wind, solar, geothermal, or the sea-based energy. What can be done with that? So people predicted that, yes, we have found a new element, and this is the problem solver to attain the decarbonization. However, a deeper dive and looking at that, we can only come to know that it can supplement the renewable energies. So wind, solar, geothermal, or other energies are likely to be there, and they will also have to be exploited for decarbonization. But this hydrogen, if it is used as a fuel, will supplement that, and the pace of decarbonization can be faster. So this is something to be understood, and that is why people are concentrating or giving attention to that. And it is more of a billion-dollar investment, which is likely to happen in the near future. So unlike the primary sources like coal, natural gas, which when explode, and we can directly use them as fuel. But here, in the case of hydrogen, it has to be produced. So it's not a primary energy source. It has to be extracted, or it has to be separated out or split from a compound, and then we have to use it. So this is where the problem of hydrogen as a fuel starts, that we have to use energy in some form or other, so that the whatever be the compound, we split hydrogen, and then the hydrogen is put to use. It's of course a versatile fuel in the sense that we can use it for electricity production, it can be used for heating, and as you know that the hydrogen with nitrogen can become ammonia, and from ammonia we can use fertilizers, etc. And interestingly, what is happening is that it is finding a greater use in these heavy duty industries like steel production, wherein like a company like Nippon Steel has come up with a process of substituting some of these carbon fuel with hydrogen, and it has been very successful. and the technology is likely to be sold to various countries. So mostly we can see in future that people, when they switch over from carbon-based fuels to hydrogen-based, we will see the steel industry getting its prominence. In fact, if you really see that there are initiatives like responsible steel production as a sort of a certification is there, and a lot of efforts are being done in this area. The properties, when it comes, we know that hydrogen is colorless, odorless, and not toxic. So these are the advantages in the sense that we don't have a problem like diesel, petrol, or other carbonaceous compounds which has some offensive smell, or it has its own safety data requirements to be taken care of. However, we look at it, the risk of ignition is 14 times, it is lighter, risk of ignition is there, and it becomes a big problem if we see that it just explodes. So we need to handle it very carefully in the processes, and it is very much lighter than air, 14 times lighter than air, and it's a very high dispersion. Suppose we imagine we have a bottle of hydrogen and we open that, within 1 second it can go up to 80 meters. So that is a sort of dispersion which we see with the property of hydrogen. And if it has a fire, catches a fire, the flame visibility is very difficult to be detected. So we require thermal sensors. So when we put hydrogen to use, and should there be a sort of an emergency situation, we require these sophisticated instrumentation attached to it to see to it that we are in a position to identify and take care of the emergency situations. Of course, it is very low density, so that is why it just rises up and goes up into the atmosphere. And we know of the two isotopes of hydrogen, that is deuterium and tritium. Deuterium is what we call as the heavy water, and this has been a very important fuel in the nuclear reactors. And if you know, or if you must have heard, there is a heavy water plant in Talcher, which the government installed, and the second one came in Kripko near Surat. Of course, I think whether they are functioning effectively or not, I am not aware of it, because I was involved in the inspection of the heavy water plant at Kripko way back in late 1980s. So that is about hydrogen. So the properties and the things which make it good enough for us to look at how hydrogen can be used. So when we go to the history of it, it was there during the Big Bang, following the Big Bang theory, which we have all read. And it was identified by English chemist Cavendish. But however, the French chemist gave it as the name hydrogen in 1783. So interestingly, if you see, hydrogen is not something new which has come out of the blue or something like that. It has been in existence, it has been put to use, but now we are tapping it as a fuel to see how best we can address the issue of decarbonization. So it was split as hydrogen and oxygen from water in 1800. Then it was used in fuel cell subsequently, and fertilizer, ammonia fertilizer was made. And subsequently, one of the first uses as a fuel was in the hydrogen rocket by Pratt and Whitney. Pratt and Whitney is an American company which makes engines. The Pratt and Whitney engines are very famous for all these aircrafts, Boeing and other companies which manufacture aircrafts. So they tried to use it in 1962, and subsequently the hydrogen car was made by General Motors, and subsequently a bus was made in USA. And for your information, if you are closely gone through the news, we have hydrogen buses being put for Kumbh Mela in India. Okay, it has come in the news. So it was, I mean, made, constructed way back in 1998. And 2020, the first truck was made with the hydrogen as the fuel. So this is the progress of the use of hydrogen in various areas. And hydrogen economy as something, as when we talk about economy, we talk about the production, we talk about the storage, we talk about the distribution, and we talk about the usage. And in case there is a requirement of a disposal, how do we go about doing that? So hydrogen economy emerged in 1970s, and subsequently it was used as a fuel for a submarine in 2004. And it progressed. And during the COVID period between 2019 or 18 to 2021, the progress has been phenomenal in this area. Many of the countries came up with strategies, many countries came up with plans as to how to tap this as a fuel. And one of the interesting thing what we see is that the hydrogen powered oven city, which is coming up in Japan, this is by Toyota and Enros Corporation, which is at the foothills of Mount Fuji. They have converted the old Toyota factory into a hydrogen city where it will be open to public. And the first phase is likely to be finished in 2025, and the second phase is 2026, and it will be opened to public, where people can go from any country, do research in the area of hydrogen and come up with their patents or products and whatnot. So this is something, an interesting development if we see in the area of hydrogen economy. And as all of us know, and we have also read, it is something which is very important. It should have been in the first page of any newspaper. But of course, we Indians do not celebrate this. The basic thing is that in 2025, we are going to have the Indian train, which will be on the tracks with the most powerful engine in the world. So it is said to be the most powerful engine which has been put in the rail. And we are one among the top 4 countries where the hydrogen economy is likely to flourish. And this is something what they predict is India to be a powerhouse of hydrogen, and it is going to drive the economy all over the world. So that is about the history. Now, when we come to the production of hydrogen, the hydrogen, as we see that it's everywhere, and how we produce matters. And that is how they have been categorized as with various colors, giving an indication or reference to the process in which it has been produced or manufactured, we can say that. So gray or black hydrogen is the gasification of coal. Normally, as we see, coal is a carbon plus hydrogen, and reforming them in the natural gas without carbon capture. So this is the gray or black hydrogen is what is prevalent today throughout the world. 90% of the hydrogen production is all gray or black hydrogen, what we see, because the CO2 is led to atmosphere. The next one is the blue hydrogen, where there is a reforming method, the steam methane reforming, wherein methane and steam, they are put together with a reaction, and the hydrogen is produced with carbon capture. So the difference here between black and blue is the way the carbon dioxide or the emissions are captured and stored. Green hydrogen is of interest to us. What we are going to talk today is by the electrolysis of water with renewable power. So the most important or the fundamental difference is that when we say green hydrogen, it is something produced. The hydrogen is produced in the similar way what with the other processes, but using renewable energy. So that makes the process the sustainable, and it is a green energy for us to be used, or which can be used by industries. So we have other things which are there, like a pink hydrogen with using nuclear power. This is what France is trying to explore, because France as a country, you know that it has 70% nuclear power, and which has been kept idle because of these nuclear, after post Chernobyl. There has been a lot of precautionary principle which has been adopted by countries, and this is again taking a new turn to use nuclear power for manufacture of hydrogen. We have, of course, the turquoise and the white type of hydrogen by pyrolysis method and gasification of biomass, which is available. So what we have is a variety of the hydrogen based on the color codification is given based on the way it is produced. So this is something to be understood, because commonly they will say, is your hydrogen gray or black or green? How do we know it's green? How do we know it's pink? Like that. So we need, the producer has to give or demonstrate the way the product has been produced. So we have like these various colors which are there just for our understanding purposes. And now our focus is on green hydrogen. As we said, we talked about that green hydrogen using renewable energy as a fuel is gaining momentum. So greater than 90%, as I indicated to you, is the hydrogen produced through the SMR process, steam methane reforming for industrial scale. So wherever hydrogen is required for industrial processes, it is produced by the steam methane refining. And it is there. And if we look at the world economy now, China is the largest producer of hydrogen in the world. It's a superpower with regard to hydrogen. But most of its hydrogen are produced with the steam methane reforming process. Now, what happens in that is that it releases high carbon monoxide, carbon dioxide, which we know that it is a contributor to the global warming, and a high heat requirement is essential for its production. So what is the alternative? How do we go about addressing this? Is through green hydrogen, the use of renewable energy. It is sustainable. We say that if we use water and produce hydrogen out of it, the waste is only water which comes. It is renewable because we are using renewable energy. The green hydrogen which is produced can be stored. Of course, in cryogenic conditions, it has to be stored, but the technology for storage, transportation, mitigation, in case if there are any other gases which are mixed up, the purification can be done. It is versatile in the sense it can be stored as a pure hydrogen. You can convert it to ammonia and it can be shipped. It can be taken to the place, and then hydrogen can be produced in the way through fuel cells or batteries or whatever it is. So it becomes very versatile product if we see that. And of course it is compressible, so it can be like our compressed air cylinders or compressed gases which are being transported across the world in ships. It can be shipped easily. Now the only thing, the other side of it is, as of now, if we see that it is terribly expensive to produce because of the requirements, the availability of renewable energy which is to be there, and also the requirements which are there, the electrolyzers which have to be used to split water. These are all expensive, as we will discuss little why. I mean, in a little while we will discuss the challenges which are there. And limited infrastructure, as I told you, we don't have much of very high amount of renewable energy projects which are there. Maybe here and there some wind energy and solar energy is there. And we require lot more of these projects so that we will be in a position to produce green hydrogen. And water demand is a issue. Now, if you look at it, India as a country, they predict India to be a water-starved country by 2050. This is the prediction which is there. So today we have Ganges, Yamuna, and whatnots, but across India there is likely to be a heavy water shortage because of the climatic changes and because of the use of water, or rather misuse or abuse of water, whatever it is. And this is the situation what is being forecast now. And of course, the cost consideration is there. So this is something to be looked at. The economy of scale is what is very important, right? Now, production process, when it comes to, we have three types of production processes of now. Very simple process, which we have all read in our schools and colleges, but the technology is the one which makes it look very important. One is the alkaline electrolysis, which is cost effective, which we have the electrolyzer in the liquid form, and we have the anode and cathode, and you pass the current and you split the water as hydrogen and oxygen. We have the next one, which is the proton exchange membrane. We have specialized electrolyzers which are there, and this is where the presence or the requirement of rare earth comes in. So we have these rare earth elements which are used as electrolyzers, and this proton exchange membrane is very efficient in producing the hydrogen, but it is very expensive equally. And the third one is the solid oxide electrolysis cell. So operates at very high temperature, but very high efficiency. So don't worry about these technological terms and all. I just wanted to introduce to you the various ways and methods by which hydrogen can be produced on an industrial scale. Now, this requires a lot of expensive materials like iridium, yttrium, lanthanum, gadolinium, tantalum, and zirconium. So these are all rare earth metals which are there. That's why I told you about our periodic table. You have what is called as a lanthanum series of metals which are called as rare earth elements. And these do not occur in the earth as a separate element. Like, for example, if there is a platinum mine and platinum is mined, along with that you get some iridium. And this iridium must be separated out and then it can be put to use. And also other materials like cobalt, nickel, zinc, platinum, iridium, like I had indicated again, iridium, aluminum, and lithium. These are all those things because they occur with something else. They require to be mined, separated out, and then it has to be used. So interestingly, why this is becoming expensive or other materials is basically because China as a country has taken possession of every place throughout the world. So we are all dependent. We means the whole world is dependent on China to give rare earth. So they are coming up with how to go about getting these rare earth materials or through other sources, or how do we come up with the activities of this. And that is where the new topics of extraction of these materials through what we call as urban mining. I don't know whether you have heard of it. Urban mining is being thought of. It's more of a circular economy approach, which is being planned so that we are in a position to extract from the waste, from lithium ion batteries or other batteries which are thrown out, we will be in a position to extract. It's much better to extract from the urban area than to go to the mines and extract them. So that's why the term urban mining is used. So it's likely to be a prospective area in the days to come, in the waste to energy process, which is likely to be there. So innovation drives improvements in efficiency and cost. This is what we see. Now, just to have an understanding of it, I'm just showing you the picture of the alkaline electrolysis, which is there as a cell, the diaphragm, where you have a liquid which is there, and you have the water which goes in the cathode and anode, and hydrogen is split and the oxygen comes out. Similarly, the same thing with a solid electrolysis, where we have these rare earth compounds which are packed in the solid form, and in the PEM electrolysis, as I indicated to you, these are all in a sometimes in a semi-solid or in the solid form. These electrolyzers help in the separation of the water and to hydrogen and also the oxygen part of it. So this is something just for our understanding purposes. Now, one question comes, what do we do in the existing infrastructure if it is there? Can we retrofit some of these things which have been using diesel, petrol, or furnace oil and various other oils, mostly with because of the technology or the industrialization with carbon economy? What can be done with that? If you look at it, for the existing units, these upgrade can be scheduled with outages to minimize the plant, and it's not a big problem to switch the hydrogen fuel from the existing fuel which is being used. Now, the next question which comes is that when it comes to operating a gas turbine on hydrogen, because now we have gas turbine ships are there, gas turbine based power industries are there to generate power. So because hydrogen is more flammable than the natural gas, critical aspects have to be considered with regard to the safe operation of hydrogen, because explosion is a possibility when we use hydrogen. And the gas turbine enclosure with ventilation is required. If there are some confined spaces, it creates a problem for people who work there, and it may suffocate the people who are there because it is colorless and odorless. So only the effect can be seen in those areas. So this is something, a hazardous gas, the flame detection with typical hydrocarbon fuels need to be supplemented with detecting hydrogen. So the sensors which have to be there, those instrumentation and other things, of course, it has a cost attached to that than our petrol or diesel fire. If hazards are there, it can be easily be seen. Now, what are those challenges when we come to green hydrogen? We are looking at how this green hydrogen can drive the hydrogen economy. One is production cost. If we see that putting a plant and in a place where renewable energy is there, so the land has to be acquired and it has to be feasible enough to put the plant, the instrumentation, measurement, every other things become a challenge. So the cost is a consideration. Of course, even we look at it, many companies are showing interest, and like typically it is, to put it simply, the hydrogen economy today is like the internet which was 25 years ago. So 25 years ago, internet was very expensive. If we want to see a newspaper, this thing, to go and log in and do that, it was a very big thing. So similarly, the situation is like this, but over the years and post 2030, that is what is the expectation, that it is going to accelerate at a rapid pace. However, there are challenges. So renewable energy requirement becomes very important because we are looking at a green hydrogen. So there has to be a solar plant, there has to be a wind energy availability, or there has to be a tidal energy or geothermal energy which must be there, with which we can produce the green hydrogen. So this is something as a challenge if we look at it. And competition is there as to who can produce and what is the volume, return on investment, the scale, economics of scale, everything has to be taken into consideration. So that is why, as on date, the hydrogen as a fuel is being used in very large types of industries like steel plants, power production, transportation by ships in the shipping industry and all. We are not looking at having hydrogen fueled motorbikes or hydrogen fueled kitchen equipments and whatnots. That is likely to take a long time, but that is what is likely to happen in the near future. The technology is being developed for these things, right? The second thing is the demand as of now is totally unpredictable. If we see that many of these companies which came up with a bang of producing hydrogen and they said they will aid the decarbonization went bankrupt. So this is the market situation. So what we see, as I indicated, many of these companies, 2025 is going to be a year of consolidation, and we don't know, many of our Indian companies will go abroad and purchase all those defunct or the bankrupt companies and develop the technology there and start uh, selling them across the world. So this is the situation. Like if we see, for example, Europe, if we see the Nordic countries like Norway, Sweden, and Finland, they are the largest producers. Norway is one of the leading companies which is producing the maximum amount of hydrogen, which is there, the green hydrogen, and so many big plants are coming, and they are unable to sell. Like if we look at it, Italy, for example, Italy is buying these hydrogen from Norway for its power requirements. So once what is the question being asked is, on one hand you have a power shortage, you have to buy from others. So how are you going to invest in the days to come for producing hydrogen fuel? You require finance also. So this is the situation. Like Spain is a big country producing green hydrogen. They would like to ship it to the Eastern Europe, but France is not allowing them to put a pipeline through France and ship it to other countries. So there is a lot of geopolitical issues also associated with this economy, the hydrogen economy, and the market dynamics is so volatile that whether to put money or not, or wait and watch. So this is the situation when we look at it with regard to the hydrogen economy as of now. The next is about the social license for hydrogen projects. So once it is put, the trust, people will have to get the trust of its usage. For example, nobody asks anything about petrol or diesel. You want to buy petrol? Okay, I buy petrol from petrol pump and then use it. And whether the price increases or goes down, okay, for 2 days we talk and then go ahead with our touring or going to hill station and whatnot. It goes on, right? Whereas this is a totally a new technology, like whether it will explode, what is the availability of that. If I use a hydrogen car and it goes and stops somewhere in the midst of forest, where will I get hydrogen then? So these are all those questions. The trust and the acceptability is what we call as the social license. Like we have the license, regulatory license, what we say as the license given by the government, like car driving license type. We have also the financial license, in the sense that you are allowed to invest in this country or in this industry, you get a financial license. Whereas when we look at a social license, it is the acceptance by the society which is intangible. It has to be developed over a period of time, and the hydrogen industry is trying to do that, if we look at it, right? The second thing is that about the other thing is that I talked about these rare earth availability, the gadolinium and lanthanum and whatnots. Interestingly, if we look at it, a compound like gadolinium telluride, okay, So don't get foxed by these terminologies. I'm just explaining to you for understanding of how the economy goes. Gadolinium telluride. Tellurium is again a rare earth. Gadolinium is a rare earth. The gadolinium telluride, if you use it, it just spontaneously at room temperature produces hydrogen. No need for power and whatnot, heavy duty power and other things. So if we are in a position to come up with the technology of using these gadolinium telluride or lanthanum doped cobalt and various other combinations which are there, it is easy to get hydrogen and the economy of scale will be very high, right? So, but as I indicated to you, the whole thing is now controlled by China and Europe and other people. They are looking at how to come up with this. They are exploring it, extracting it, and so much of research is going on in this. And when we look at the value chain issues with regard to that, it's not though like a chemical industry only, if we look at it. But the issue is if we put a plant somewhere in the coastline, and if a valve, flange, or something leaks, now we have to take that valve and then fit it, and there is a breakdown maintenance or shutdown, everything happens. So this is something which is very critical. So the industry is now looking at how do we look at the value chain for availability of materials, and many of these are stainless steel or maybe other alloy steels, etc., or alloys which find use in the production process on the equipments. So this is somewhere people are working on to see that the value chain, or what we call as the supply chain in simple terms, is robust enough to sustain the industry. Otherwise, we have a big plant which is there and it starts leaking, and then we have to wait for a valve or a change of equipment or electrolyzer for maybe 2 months. So it is more like a white elephant for the company which has put the plant. So this is an area where the focus is being given extensively, and we will see in the days to come a considerable amount of change or momentum in this area. The applications and usage at present, it is basically focusing where is this technology being used as on date. It is not at a domestic scale, it is not at a small transportation scale or industry scale like that. It is hard to abate sectors. Hard to abate means those areas where it is difficult to reduce the impact of carbon economy. So it is now being looked at in the shipping industry. So all the ships may be fueled by hydrogen in the days to come, and it is being looked at in the transportation industry. That is why we have hydrogen trains, mass transportation which are there, the hydrogen trucks and other things are being looked at, and slowly maybe it will extend its arms to other types of industries. And we have green ammonia, which is there and which is being produced and shipped to various countries. And from ammonia, we can easily split the nitrogen and hydrogen for use. So this is the scenario we have these things happening, and it is an exciting period if we see for the hydrogen economy. And 2025, as some of these producers, they feel that it is going to be a year of consolidation. All these companies which started with a bang will end up with a bang, and those who can sustain the market and their technology and one-upmanship, they are going to survive in the days to come. And there may be mergers, acquisitions, and so many things happening in the 2025, and which we are going to see in the days to come. So when we look at some of these things, the strategies worldwide, most of the countries, like 50 countries, have published strategies with regard to the use of hydrogen. Of course, India is also one. It is by the International Renewable Energy Agency, which has published a report in 2024, which is available. You can go through that if you are interested. And one of the first country to look at hydrogen, the use of hydrogen, is Japan. That's why we see Japan has used it in the Nippon Steel for steel production, and they are finding it. And these cities like that Toyota woven cities coming up, and they are giving a thrust on the use of hydrogen for various processes. And China, as I indicated to you, is a global leader in the production and consumption. They consume considerable amount of hydrogen in their processes for production of various items. And US has come up with a clean energy strategy, a roadmap for coming up with, you know, 50 million tons by 2050, and they want to have 10 million tons. So the US has its own strategy. EU, all of us know that about the national hydrogen strategy in 2020. It has been published. So all these countries, if we look at it, within the span of 5 years, they have come up with strategy document and also the movement towards usage of hydrogen in various processes. If we look at, for example, CBAM, we had some talk. Kulkarni had given a talk some time ago about CBAM, that is the cross border adjustment mechanism or cross boundary adjustment mechanism on carbon tax. So, if you look at it closely, 6 sectors have been included. One is the steel, second is the aluminium, third is the electricity, hydrogen, and ammonia. So these have all been included as this one of the 6 sectors. So hydrogen, the green hydrogen and the green ammonia has been included, basically because it should not be produced with embedded carbon, because it can be a gray or black hydrogen which is produced and it is being used in Europe, and that means that the emission is not getting reduced at all. So there is a tax levy which has been put, and that is why in CBAM we have this included. Now, France, as I indicated to you, plans to use nuclear energy, and some of the EU countries are exporters and some are importers. As I told you, Norway is a very big exporter of this green hydrogen. Italy is an importer. Spain is an exporter, but when we look at the East European countries, they are all importers. Nothing much is seen. So when we look at Europe, just like that, it's a very complex situation where transfer takes place from one area to other, but the investment is what is being looked at to see to it that this industry or this the economy develops. So Australia has again come up with a national hydrogen strategy just last year, and they are trying to come up with newer initiatives, of course, with India also, as I will show you some of the things. Now, I just wanted to show you how this plant looks like, just for our understanding purpose. Now, this is the largest alkaline hydrogen electrolyzer, as I showed you, 3 processes: the PEM process, the solid oxide process, and alkaline hydrogen production process. And this is the one which has been opened in August 2024, the world's largest producer at the cheapest price. If you see that, produce 1 kg of hydrogen with 43.09 kilowatt hour of electricity. Now, people are looking at it, other Europeans are looking at it, US people. How is it that these people have come up with this? How are they going to maintain this if there is a breakdown, shutdown? It's such a huge this thing, and to maintain it is a big problem. So they are wondering, and as to how things are going to come up with China. It's something interesting to be seen in the days to come, right? Now, if we look at some of those plants, this is a plant, Yara, the largest hydrogen, green hydrogen producing plant in Norway. And interestingly, this company Yara has come for an agreement with another company in India called Acme. And Acme is a company in Gurgaon. They are into renewable energy. They have put some pilot plant in Rajasthan, Mangalore, and other places for this with producing hydrogen and being used for various purposes, are producing green ammonia and all. So this is the section. What I am showing you is the ammonia conversion section, that from here it is given to the conversion to ammonia, and the gas will be taken and this thing. So you can have a look. I mean, a look at it indicates how much of these equipments and other things. It looks like a normal chemical plant, but the value chain, as I told you, the spares and equipments and other things which are required, the electrolyzer which is required, this is something challenging. And this has come up in, this is the largest plant which is opened in 2024 in Norway, if you see that. Now, this is another view as to where these hydrogen plants can come in a picturesque place like this, where renewable energy is available. It can come in the midst of a forest if some wind energy is available. So what I meant to say is that it can come up in anywhere, any location where that renewable energy is always available, or it can be made available. There are no specific land related requirements which are there for green energy, or rather green hydrogen or green ammonia production. So one of the largest facility which has come up is in the Saudi Arabia, which is supposed to be the largest. Of course, they say that India has one of the largest facilities for the solar power plant, and because we require renewable energy, this is now considered as the NEOM project, because in Saudi Arabia it's desert. You can put everywhere solar panels, and with that you can generate electricity. Maybe it's in the area of maybe 300 acres or so. I don't know exactly, but it's a huge area where the investment has gone. This is the largest utility scale commercially based hydrogen facility which is come up, and it is functioning as on date. So this is the extent. Why I am showing this is the rapidity with which the economy is changing, and that is with regard to world. So what is happening in India? India, we have this MNRE, the Ministry of New Renewable Energy. They have taken initiative subsequent to what is happening world over, and they came up with, if you look at the Glasgow COP, which happened, I think COP 28 or 26, I don't know, this thing, they came up with a formula called Panchamrit. Okay, Panchamrit means 5 important things what India will do. One is, India is likely to become carbon rather net zero by 2070, come up with a 500 gigawatt of power. Like that, they had given 5 goals, which they call it as the Panchamrit. Okay, so it's more of an attractive term so that it's easy to understand that. So that mission, which has triggered the National Green Hydrogen Mission in 2023, and our government, the prime minister, when he went to the meetings of G7 and Quad and other places, and there were talks about selling hydrogen, selling ammonia, green hydrogen and ammonia. And this is the diplomacy which is going on from the political side of the hydrogen economy. And Australia, as we saw, the strategy has been made in 2024. They formed Australia-India task force on hydrogen. And similarly, the Quad, the four countries which are there, where India is also a member, a lot of talks are going on to how to sell this. the green hydrogen, produce green hydrogen and export them, it becomes an exportable commodity by ships or by any other means to neighboring countries. So Acme, as I told you, is a private company. I just wanted to give a flavor of what is happening in India. So this is a company, and they have come up with three green ammonia projects in India. One in Rajasthan, another one, and I think in Mangalore and other places. And it's likely to expand. So they have gone in for a collaboration with the Norwegian company, as I told you. So it's a very leading company. And I think the technology transfer, if it happens, then we will see bigger plants in India producing green hydrogen or green ammonia. And of course, not to be left out, all our big companies are now focusing on this for green energy purposes. Reliance, Adani, NTPC, everybody is now putting their money into this green hydrogen. So this is likely to be the future, what we can see when we do transfer from, or the process of decarbonization takes place in the days to come. So India plans 19,500 megawatt for interstate transmission for green hydrogen by, this is financial year 30. So this is something which is important for the interstate transmission itself, that you produce the green energy or green hydrogen, use green hydrogen to produce energy, and it can cut across and be sent to various states, so that the transmission cost and other things may come down in the days to come. And if you look at it, Gujarat is a key player, as always the case, because of a lot of industries which are there, and many projects are coming up for this green hydrogen. And on the other side, if we see that Tamil Nadu is a renewable energy leader, because it has a lot of wind power in the side of Kanyakumari and the southern tip of India, the coastal Tamil Nadu, which has a lot of wind farms, wherein it can be used to tap, and green hydrogen is production is a possibility. But however, Gujarat is now the player now. Now, when we come to regulatory framework, I just wanted to discuss this basically to understand what are these regulations. Though it's a new technology which is coming up, it's not a, the process is somewhat easier to understand but difficult to implement. What are those legislative things which are to be given attention to? When we look at it, the interesting thing is there is no comprehensive regulatory framework as of now in India. Okay, there are five agencies who have been contacted. One is the BIS, Bureau of Indian Standards. Then we have this OISD, Oil Industry Safety Directorate. Then we have the Gas Authority, and all the gas transmission companies, and these things, they have been uh, given in charge to look at how to come up with standards, how to come up with the specifications, requirements, which is applicable to India in line with the international requirements. So things are being worked out, and this is a part of the green mission, what our green hydrogen mission 2023 documents all these things. And as of now, any project with regard to the green hydrogen, central government controls it, as always the case. And of course, the state government has to provide permission for the land and other things, every other requirements. And one interesting thing, if you see, is that this is a new technology. It's going to come up. So EIA is not a requirement. That is, environment impact assessment is not made as a requirement. You know the issue of environment impact assessment, because then you have to come up with a complete study of the area, the geological requirements, the public, the biodiversity, everything to be taken. You have to come up with an impact assessment and plan, and this has to go for public hearing. And you know the problems of public hearing today. Somebody will raise a flag and say, this plant is hazardous, we won't allow this, or this may explode, and we will be all be in trouble. So many things, misinformation, fake information being available. So it's a very big thing for that. So as of now, this industry does not require the EIA requirement. So we have to see as how big the plants come and when the government may change its position. This is a question mark as of now. Public liability insurance, if we see, basically is what? Wherever we have hazardous gases, and should there be a leakage or an issue or anything which damages the neighboring environment, then it becomes the liabilities on the company to provide insurance, as we have seen in Bhopal tragedy or DCM tragedy and whatnots. The public got affected and they had to be given, and it is the principle of absolute responsibility, as we say in environmental law terms. Principle of absolute responsibility lies with the company. So as of now, it is not there, but we don't know. If the plants become very high, this has to be looked at. And continuous emission monitoring systems is made as a mandatory requirement by Central Pollution Control Board, with a threshold which is given as 2 kg of the emissions which can be tolerated. These are all specified. In other words, like similar to other chemical companies, continuous emission monitoring is required by the hydrogen industry wherever it is put. And green hydrogen standards and approval systems are being made by Council for Energy and Environment and Water, which has come up in May 24. And this will be the foundation with which the other regulations may come up. And agencies list of standards, collaborations included in the approval document as to who will do, what are the things they will do, etc. So it's something which is happening. So coming to the end of it, if we look at it, net zero is the driver for green hydrogen. So this whole economy of decarbonization, and this has come as a solution, hydrogen. So this is going to drive initiatives through value chain. I indicated to you those cumbersome issues and issues which are coming up, and this will have to be ironed out. The availability of spares, materials, equipments, electrolyzer, etc., everything, the shipment part of it, all these things are being looked at. So I think there will be improvement in the days to come. Adoption of circular economy will be high. As I told you, the availability of rare earth, urban mining, and new processes will come to extract these rare earth materials and other elements, to see that it can be put to a sustainable use. We have the energy storage and flexibility. This is something we have to have, like a petrol pump. Similar to that, we have to have a hydrogen pump where the vehicles can go and take the trucks or other things, or ships, if they want to have this fuel loaded. We'll have to have the storage and facilities and flexibility for that. And fuel cells, batteries, what we are looking at is becoming a very promising area. Just today only I was looking at morning, one of the largest battery storage locations, it got a big fire, and it's in a mess in US, if we see that. On the other side of it, like one of the Australian companies asked Elon Musk, can you put a very large battery storage yard in Australia? And he said, I will do it in 100 days. If it crosses 100 days, I won't take a single dollar. So this was a challenge, and he did it. And that is the way, the rapidity with which the things are moving with regard to the battery storage process. And we find that the economic growth is likely to be there, of course, because of this job creation. People will be required to know about hydrogen handling, hydrogen safety, and hydrogen management, etc., etc., all those things. So today, if we see that green hydrogen will become the 21st century oil, like what happened in 1970 when oil was considered as a gold, liquid gold, and OPEC countries and everybody started extracting oil. Nigeria came up with the oil economy and everything. The whole thing is likely to change in the days to come. And this is what is the prediction by Forbes magazine, which has indicated to about the hydrogen part of it. Okay. So now I don't know, I have exceeded time or I do not know. Kulkarni sir,
Yes, sir.
and if there are any questions from our friends, a couple of questions we can take. Somebody wants to know anything? Yeah.
Sure, sir. So it was a wonderful session, and I really like the way you also included the very basics of what is hydrogen. So from basic to PhD level, so everything we got during this short period of time. So it's okay if we are exceeding
Yeah.
couple
Yeah.
of minutes. So it was a
Yeah.
hard work
Yeah.
to make it simple. Yeah.
Anybody has any questions? Please.
If anybody is having any question, any doubt, please you can ask now.
So,
Sir,
good evening,
sir,
sir.
Yeah. 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 Yeah.
Yes, Sairam, you go first.
Oh, good evening,
Yeah.
Mr. Muralidharan, sir.
Yeah.
As a part of, I'm a assistant manager safety from Ramco Cements Limited. I'm learning
Ramco.
this.
Okay. Hmm.
I'm learning this ESG concept from Mr. Dhananjay Kulkarni.
Okay.
Coming to my question is that, as a ESG
Hmm.
part of you, how this hydrogen concept is related to
Yeah.
this? What, and what ways? I want to know whether it related to the circular economy, what you said in the middle of
when
the.
when we are as you have said, indicated, you have learnt about ESG, correct?
Yes, sir.
One of the fundamental, one of the important issue which is facing now in E component is climate change, right?
Yes,
And
sir.
people are looking at the decarbonization, right? And
Yes, sir.
one of, since you say you are from cement industry is one of the industries which consumes very high power. You must have read about it. And
Yes, sir,
people
sir.
are now looking at green cement. Producing green cement is what is being looked at. In fact, cement is also a part of the CBAM, which is included in the sector, right?
Yes, sir.
So when we look at it, the process, the energy requirement will have to change. And if that is required, hydrogen can be used as a fuel to produce electricity. Okay, instead of burning coal or instead of getting into other forms of energy, this, if it is there, it's possible. So that is how it is going to trigger. So, in simple terms, to answer to your question, sir, is that wherever you see petrol, diesel, or furnace oil, think hydrogen. That's all.
Okay,
Okay.
sir. Thank you, sir.
Yes.
Yeah.
Thank you so much, sir. So
Yeah.
there are a couple of questions. I'll
Yeah.
just
Yeah.
uh,
Yeah. Yeah.
shoot them for a short answer.
Yeah. Yeah. Yeah.
So
Please.
one question is, as it is highly inflammable and it is high, let's say it leakage possibility, right? So it has,
Hmm. Hmm. Hmm.
so it is, then is it safe or is it possible to store it in cars or other
Yeah.
commercial
Yeah. Yeah.
vehicles?
It is
So
going
that
to
is,
come. That is what you have all these gas powered cars, now.
yeah,
You have cylinders kept, some taxis, other fellows are keeping it. Of course, it is still considered dangerous in the present circumstances, but people are working on that. How to go about and what should be the safety measures, which are, that is a separate subject,
right,
and the technology part itself. So people are working on that. So we will see, maybe with a different material and different sort of a container which is there. It's not, I wouldn't say explosion proof, but the intensity of explosion could reduce, right?
right,
Today, if we look at it, hydrogen is extensively used for the hydrogenated products. If you see our dalda,
right,
or vanaspati, any industry, process itself has to use hydrogen. But
Right.
there it is used as a process chemical, not as a fuel. But now
Right.
we are looking at using it as a fuel. So obviously, a lot of standard. That's why BIS, other people are working on standards, and we will see some things coming up in days to come. Yeah.
Yeah. Right.
Yeah, Muralidharan sir, I have a one question. As you said, hydrogen is itself not a source of energy.
Yes.
So how it create 43.6 megawatt energy, kilowatt energy? What is the medium through which hydrogen is
Renewable,
converted to?
renewable energy.
No, no. My question is that hydrogen itself not a source of energy like coal and petrol.
Correct.
So what is the medium it will get energy to the car, other source? What is the through a cell or through a medium? What is
To us,
the
fuel,
technology?
fuel cell,
Through a fuel cell.
fuel
And
cell. Yeah.
okay, and second thing I want to know, what is the Indian strategy to work on through the green ammonia we have to produce hydrogen or through water electrolysis? What is our choice?
Whichever, that depends on the location, that depends on the availability of the resources. Wherever the industry can go in either way. If it is a coastal area where, or a river, nearby a river, it's possible that you have a lot of water available. So water has to be pumped in, hydrogen to be removed, and the water sent back. Right? It is possible. But if it is in other location, they will have to look at the ammonia processing if it is feasible, like a fertilizer factory or somewhere where you have nitrogen compounds which are getting out from the company as a byproduct or something like that. You can use that nitrogen compound, split it, the oxygen and nitrogen, add hydrogen and make it as green ammonia. Possible.
Yes, sir. But so in India context, it will seen both or the cases are quite difficult, both because water is not available in large quantity,
Okay.
basically the fresh water, which is good for the electrolysis.
There is no requirement of fresh water. Okay, even your sewage water has hydrogen. Only thing is that sewage water, which is that is what our Nitin Gadkari was telling. It could be a big source. Whatever the municipal water which goes out, if you are able to clean and treat the water, come up with a decent specification, put it to electrolysis, you will be in a position to look at the make hydrogen out of it. It's possible.
So pure
Not
water
that
is not required.
no
Pure
no
water is
no
not required for
no no
electrolysis.
no 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 no.
So
You can
electrode will work.
from the, that's what I am telling. From the dirty water which is there, it can be treated to the required specification and then put to use. We need not have a Ganges water or some very pure water and whatnots. Okay.
Okay.
It's possible. Like even if there is a huge lake which is filled by rains during monsoon, and if it is of a larger size, there could be a reasonably good plant which can come up in that area.
No
Okay.
high level treatment is required. Only by some basic treatment it can be used for
Yeah, yeah,
electrolysis.
yeah, 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 yeah. Yeah. Of course, we have to look at all. That's the technology, the efficiency part of it. Everything will come. So that is what we have to look at as
Sir,
how the
good
efficiency.
evening, sir. Am
Yes.
I audible, sir?
Yeah, yeah, very much. Yeah,
Sir, actually, since hydrogen is also inflammable and there are a lot of risks associated with hydrogen,
yeah,
and we need a clean energy source, like
mm,
renewable energy.
yeah.
Why India is not really looking into nuclear power plants? Again, it is something, it will give a clean energy, green energy.
Of
At the
course.
same time, the requirement of the land like solar
Uh,
and wind, we need a large land parcel. It can also be
yeah,
reduced.
yeah,
So again, it requires a coastal atmosphere also.
correct.
So because Europe and some other countries, they are doing it. So
Mm,
I think even Indian people, now they are restricting their constrained towards nuclear power. But again, when hydrogen comes up, the same issue will come up because it is also inflammable. It is also dangerous.
Of
So
course.
why can't this be
See,
done?
that's what you have to understand, that whenever a new technology comes, you should have that sort of a capability to address those risk factors which may come up. Suppose if they try to use the nuclear energy and it creates a mini Chernobyl, then it will be a big
Mm,
problem, right? In India,
okay,
if you
okay.
see that. So they are watching what is being done in France, because France has
Mm,
very established infrastructure. They have been dependent on nuclear energy. And if they are in a position to succeed, of course, India
mm,
has a good relationship with France and they will buy the technology and come up with this.
mm.
Obviously,
Yes, sir.
it's more of a
My point
supply
is,
demand. Yeah.
yeah. So it should be a mix again, mix of all.
Yeah. Yeah.
We should not rely on only on
Everything.
solar or wind or
Yeah. Yeah.
it should
Yeah.
be
Of course.
again
Of course.
diversity will come in there.
That is why, that is the interesting thing, feature of green hydrogen.
Okay,
Okay.
okay,
That is the most interesting thing with green hydrogen now.
okay, sir.
Yeah,
Okay.
it can be
Thank you.
decentralized and you
Because
can
if you
put it
look
in
at it,
multiple
for
places.
example, solar
Yeah,
energy you have, solar plant you have. If it is
yeah.
dark, nothing happens, right? If
Absolutely,
it is raining, you don't get that amount of efficiency. Whereas
absolutely.
you use that energy to make green hydrogen, that can be transported everywhere throughout the world in a
Correct,
ship,
correct.
compressed, transport, stored for any time. It can be
Mm,
used anytime where you want. Whereas the solar
absolutely.
and wind, we are dependent on the seasons. Correct?
Yeah, time of day and seasons. Correct. Yeah.
Exactly. So this is the real advantage. This is the USP, if I may put it, for green hydrogen. And that is why
Oh, great.
people are trying to pump in a lot of money
Okay.
into that. ArcelorMittal is putting $200 million now.
Yeah, yeah.
Other companies are pumping in so much. That is the
I
thing.
think it's going to be really a wonderful time in India the next 20 years.
Yeah, yeah, yeah.
Really, we are we are eagerly awaiting.
Yeah.
No,
Yeah,
we
yeah.
cannot wait. We have to do something and equip
We have to do
ourselves, upskilling.
absolutely,
And that is what
absolutely, sir.
Dhananjay is trying to do,
Yes, sir. Yes, sir.
to
Yeah.
educate
Thank
and,
you, sir.
upskill. Yeah, good.
Thank you, sir.
Yes.
Thank you.
Yeah.
Thanks a lot for the
Now,
question as well.
yeah.
Yeah.
Now
Yes,
I
sir.
will
Please.
ask only one short question, 2 minutes. I told you.
Sure.
Okay. I want one of you to answer. Okay. Now we have told that we are going to export green hydrogen to Europe. Okay, let us assume the company is producing hydrogen, green hydrogen, it's trying to export. But in India, milliwatt is common, right? They can mix anything, adulterate with this thing and put milk powder and lime and sell it and whatnots. Now you have a plant which produces green hydrogen, say 1000 tons. He is short of 200 tons. So he can bring a truck of black or gray hydrogen and fill this cylinder or whatever it is, because it is colorless, odorless. Remember. So it is just putting it, and 1000 tons he is selling it. Okay. How will you prevent adulteration? This is the question.
From traceability,
How do you have the traceability?
what amount of electrolysis used, how much conversion factor in the,
Yeah,
by the conversion factor we can determine how
yeah.
much gas is generated.
Very correct. So that is one way, you get into a scientific thing and whatnot, but in business, you won't sit and calculate 80 kg multiplied by so much and whatnot.
Advanced sensing technology.
Exactly. So this is the thing what is being looked at parallelly. If we see the application of blockchain technology in hydrogen in the economy. So this is again a
Blockchain,
separate
yeah.
new thing which is coming up. Like we discussed, Kulkarni I had one session on blockchain technology for sustainability. So here, this is something which is promising now. So parallelly, the blockchain technology for hydrogen, it is B2B, BBH2. The project is coming up. So many companies are putting their efforts to look at the traceability, as was told by Mr. Tyagi. So again, technology is going to take over. Now, in spite of blockchain, if you see that use of blockchain is very difficult because it is an energy guzzler. It takes a lot of energy. So again, they will use the renewable energy to blockchain, and that will solve all the problem. So many combinations and permutations are being looked at, and that is why it is exciting if you see that. So all software people, I don't know who are there, you will have an opportunity to work in the hydrogen economy in the days to come. Yeah. So
Yes.
that is the thing. What I want to say is, when you look at green hydrogen, the green hydrogen certification becomes very important. The traceability is important. Otherwise, you are not solving the climate crisis. You are only
Right.
multiplying it and making it miserable. So these sort of checks and balances are expected in the days to come, and we will see exciting times later on. Okay. So I think we
Yes.
can stop, Kulkarni sir. There are a lot of
Yes.
things we can discuss. We have exceeded the time. Thank you all
Yes, sir.
for your patient hearing. I hope it was useful and you could understand things as to how things are likely to go in the near future. Yeah.
Yes, sir. It was really wonderful, really engaging session. So thank you so much. And those still there are many questions in the chat, but in paucity of time we can't take
Yeah,
all.
we'll try to answer.
But I would like to share few resources if someone is interested. So first one is definitely the website of ministry, and this is the Green Hydrogen Mission document, and so you can go through it, National Green Hydrogen Mission. So this is a good resource if you want to go through it, and a couple of links that I shared in the WhatsApp group. So these are there. And also today I could see this very recent episode actually from Sunset TV, 8 January 2025. So this was about National Green Hydrogen Mission. What government is doing, and what is the let's say future trend. And from that, they are saying that in Kakinada, we have a plant for green hydrogen and ammonia, and which will start exporting this green ammonia, green hydrogen to Europe from 2026, from just next year. So these are some of the promising things that are coming over here. And of course, this is the new field, dynamic field, and everything is in a permutation and combination, so as sir said. So definitely there are more things to explore in coming future in this decade itself. All right. So thank you so much, sir. Thank you everyone for your active participation. And if you want to support this initiative, you can join Sustainability Simply Put, or it's if you want to support, so join as a member. We have a support of already so many members have joined as a paid member. So with their support, we are able to conduct this session. So thank you so much. And at the same time, thank you so much, Murli sir, for this engaging session. It was so informative. If we wanted to
It's
take this
always.
knowledge normally, we would have taken almost a week or 10 days to get it so much into this short period of time. So thank you. Thank you so much, sir.
Thank you. Thank you. I always tell Mr. Kulkarni, if nobody is there to talk, I am there. Okay. Because as one of the early patrons of this, and I feel happy to talk to people and discuss things. Thank you,
Great.
Kulkarni sir.
Wonderful.
Bye
Have a
bye.
great weekend. Thank you.
Bye. Bye.
Thank you. Thank you.
Thank you.